This is a video presentation of Chapter 4, Section 4 in the 7th grade textbook entitled Solving Proportions. Now, we actually took a small introduction to this yesterday when we were talking about identifying and writing proportions in Chapter 4, Section 3. Because really what this section is going to spend all the lesson talking about is the idea of cross products. And cross products, as you can see from the definition, is the product of the first term in one ratio and the second term in the other. So what they're saying there, really, the simple way of saying it is to multiply the diagonals in a proportion. Well, if you recall yesterday, that was the way that we checked, or one way that we checked to see if two ratios were equivalent or if two ratios formed a proportion, is we multiplied the numerator and the denominator in one ratio with the other and did the same on the other diagonal. And if the answer worked out to be the same, then we proved that yes, they were proportional, and if not, then they were not proportional. So that's how the logic puts these two sections together, in that we're doing much of the same thing here. What's going to be introduced here that was not introduced in the previous section, though, is they're going to now make a number disappear, in essence. Or in other words, make you solve or find one of the numbers that would make the proportion be valid or make the two ratios be equivalent. That will be something new. But that technique of multiplying the diagonals is exactly what we're going to continue doing here in Chapter 4, Section 4. Again, a cross product is the product of the first term in one ratio and the second term in the other. So, here, in number 1, we're going to use cross products to solve the proportion. 9 over 15 equals m over 5. And as you can see right away here, they've decided to make you find the missing number here. So, again, they've asked us to use cross products, so what they're saying to us is that multiply the diagonals. That's going to be our approach to solving here. So, on the diagonal of 9 and 5, the result is 45. So what has to be true is that when I go for the other diagonal, the result also has to be 45. So 15 times m has to equal 45, which is the work you can see shown here on the first two lines. So I'm saying, what number would I multiply by 15 to get to 45? Well, we know that 15 times 3 equals 45. So indeed, m must equal 3 here to make this proportion be valid, or to make the two ratios equivalent. And of course, 9/15 does reduce down to 3/5, so that does make good sense to us. Now, there is another technique you can employ here that might sometimes be easier. However, the technique does not always work. If we look at the denominators here that I began with originally, I had 15 and 5. Well, to travel from 15 to 5, that's pretty simple. To go from 15 to 5, I'd be dividing by 3. Well, because these two guys are equivalent, the exact same comparison has to work in the numerators, in the top spots. So as I travel from left to right in the numerators, I would also be dividing by 3. And when I take 9 and divide it by 3, no surprise, I get an answer that's exactly the same as what we calculated, 3. You can make it travel the other way if you were to need to, going from 5 to 15. That would be multiplying by 3, so going from right to left in the numerator would also be multiplying by 3. What you don't want to do is throw adding or subtracting into the mix. That will not work. But multiplying and dividing, multiplying by a whole number, multiplying by a fraction, dividing by a whole number, dividing by a fraction, that will always work here. But if you don't have something simple to work with, it's going to be more difficult. If I said, how do we get from 5 to 17.29, most of you can't easily identify what I'd multiply by 5 to get to 17.29. In which case, stick with the idea of the cross products. Here's number 2. It says 3 binders of the same size take up 4 inches of space on a shelf. Then, instead, on that shelf, they're going to put 26 binders there. and they want to know how much space those 26 binders are going to take up. So we're finding how much space we need for 26 binders. We know that 3 binders take up 4 inches of space. Well, obviously this is a story problem in the section about solving proportions, so it's a pretty good bet that they want us to write a proportion based on that information. So the first ratio says that 3 binders represent 4 inches of space. So my first ratio says just that there's 3 binders in 4 inches of space. They want us to bubble that up to represent 26 binders, and we're figuring out how much space that takes up. Now, one of the things that's important here when we're writing our proportion is some consistency. Look at this guy on the left side here. They put the number of binders being compared to the amount of space it takes up the number of inches. Binders on top, inches on the bottom. When I come over here to write my other fraction, you have to write it the exact same way. Binders on the top, inches on the bottom. If you don't like that, then you got to change it all the way around. If you want to put inches on top and binders on the bottom, that's fine, but you've got to do the exact same thing over here. You can't just say, well, that's the first number I see, so that's the first thing I'm going to write down. That doesn't work. Because I wrote this proportion with binders first and inches second, when I come over to write this guy over here, binders has to go first and inches has to go second. The exact same order. Okay, so we've got our proportion. Now we can solve it. Now this is an example of what I was talking about a minute ago. To go from 3 to 26, most of us don't know that right off the top of our head. If it was 27, pay dirt. 3 to 27 multiplying by 9. But most of us don't know how to get from 3 to 26. So we're probably not going to use that idea. We're going to instead use the cross products like this section is talking about. So I'm saying on this one diagonal, it's 4 times 26. Well, 4 times 26 is 104. On the other diagonal, it's 3 times x. So 3 times what number is 104? Well, when I take 104 and divide it by 3, I find out that the answer is 34.6 repeating, or 34 2/3. Again, I'm saying 3 times what number is 104? Because remember, both diagonals have to be the same. Since this diagonal makes 104, this other diagonal has to make 104. So 3 times whatever has to be 104. And indeed, 34 2/3 times 3 is how I get 104. And that's exactly what they're verifying down here in the bottom. Now that we've figured out that it's 34 2/3, they're showing you that when I check multiplying both diagonals, 4 times 26 and 3 times 34 2/3, the result on both ends up being 104. And since it is 104 on both, we're sure that that's the answer. So the cross products being equal, 34 2/3 fills in our spot. 26 binders takes up 34 2/3 inches. Alright, so let's go ahead and wrap this up by looking at the check it out examples here. Use cross products to solve the proportion. 6 over 7 equals m over 14. So I'm saying to myself, okay, the diagonals have to be equal here. So this one diagonal is 6 times 14. 6 times 14 is 84. So the other diagonal also has to equal 84. So I'm saying, what can I multiply by 7 to get to 84? Well, as you can see, I'm showing some work here. I'm saying that 7 times 12 must be 84. And so the answer here for m is 12. Now, if you're saying there's an easier way to solve that, you've been paying attention. To go from 7 to 14 in the denominator, we're multiplying by 2. So I'm going to do the exact same thing in the numerator at the top, and 6 times 2 does indeed give me 12. So either way you solve this one, with or without the cross products, the answer verifies as 12. Alright, number 2. John filled his new radiator with 6 pints of coolant, which is to the 10-inch mark. How many pints of coolant would be needed to fill the radiator to the 25-inch level? So, in the first sentence there, it tells us that 6 pints of coolant goes to the 10-inch mark. So I write a fraction that compares 6 pints and 10 inches. Remember, we talked a minute ago about consistency. So over here to the left, I've noted that I'm comparing pints and inches. So anything else I write is going to have to go in the exact same order, pints first and inches second. So when I come over here and they're asking me about how much it's going to take to fill to the 25-inch level, the top number, the number of pints, fills in as X. The second number is 25 inches. So 6 pints is to 10 inches, as what amount of pints is to 25 inches? Well, remember, the diagonals have to be the same here. 6 times 25 on the one diagonal is 150. So I'm saying on the other diagonal, what would I multiply by 10 to get to 150? Well, that one's pretty obvious because 6 times 25 is 150. 10 times 15 is 150. So indeed, this must be 15 to make both diagonals be 150, and that means it takes 15 pints to get to the 25-inch level.